So the last part of this topic, air and water, is about nitrogen and fertilizers. So you should be able to describe the need of nitrogen, phosphorus, and potassium containing fertilizers. What are fertilizers? Basically, compounds, the substance which can help the plants to grow well. We call them as fertilizers, or compound which provide essential nutrient to the plant so that they can grow and give a better fruits or flower. So those compounds which are used to enhance the performance, the growth of a plant, we call them as fertilizers. So describe and explain the essential condition for manufacture of ammonia. So by a Haber process. So how we can manufacture ammonia? How we can prepare ammonia? So nitrogen reacted with hydrogen N2 plus H2 gives, the reaction is reversible. So it gives ammonia which is NH3. The balance equation is N2 plus 3H2 gives 2NH3. And the forward reaction is exothermic. So if the forward reaction is exothermic, when we draw the energy profile diagram, exothermic reaction, reactants have high energy and the product is having low energy. So nitrogen and hydrogen will have high energy and ammonia NH3 will have low energy. So here N2 plus 3H2 gives 2NH3. So nitrogen and hydrogen can react to form ammonia, and ammonia can decompose and form back nitrogen and hydrogen. So because the reaction is exothermic, so if we want more ammonia, so what we should do, we should lower the temperature to increase the yield. Increase yield means if we want more ammonia, what we should do, we should lower the temperature, decrease the temperature. Then what about the pressure? Because the nitrogen, hydrogen and ammonia all are in the gaseous state. So 1 mole, 3, so 4 moles of a gas on the reactant side and 2 are there on the product side. So whenever we increase the pressure, the equilibrium will shift towards side where number of moles of gas are less. So what we should do, we should increase the, if you want to increase the yield or amount of the product, so we should increase the pressure. So this reaction should be carried out at high pressure and low temperature so that the equilibrium shifted toward the right hand side, or we'll get more ammonia. And we use iron as a catalyst. So Fe or iron is used as a catalyst. Catalyst does not affect the amount of a product, it only speed up the reaction. So what are the reaction conditions and what are the things you need? You need nitrogen and hydrogen. So what is the source of the nitrogen? The nitrogen is obtained from the air. So nitrogen is obtained from the air. And from where we can obtain hydrogen? It is from hydrocarbons or from steam. We can produce hydrogen. So when we mix nitrogen with hydrogen, it will form an ammonia. And the reaction conditions, the thing which is important is reaction condition. Iron is used as a catalyst. It prefer a low temperature, but we are using a high temperature around 450, because if we use a low temperature, the reaction will be very slow. So to make an optimum rate, that's why we are using around 450 degree centigrade. And the pressure is very high pressure. It's about 200 atmosphere or 200 times 1 into 10 to the power 5 pascal, so which is very high value. So nitrogen react with hydrogen to form ammonia. The reaction is reversible, so ammonia can break down into nitrogen and hydrogen. So on cooling, ammonia liquefy. So as a result, when ammonia is formed, we liquefy so that the equilibrium always shifted towards the right hand side. So this is how we manufacture or prepare ammonia gas. by reacting nitrogen with hydrogen using the Haber's process. So this is basically how the reaction is done. You can see like the hydrogen which we obtain by either from hydrocarbon and nitrogen from air, they compress, then we passes over the catalyst, bed of catalyst, around 200 atmospheric and 450. Then we it form ammonia, the ammonia gas cool down and we remove ammonia. The nitrogen and hydrogen still in a gas, so we again pump them and they continue. Nitrogen and hydrogen pass over the catalyst until they form ammonia, they cool down and go out. If it does not, then again they are sent up until the reaction, all of the nitrogen hydrogen convert into ammonia. So this is in terms of reversible reaction. So if you use a temperature higher, the equilibrium will shift toward the left hand side, the yield will decrease. And if you decrease the temperature as well, so rate will also decrease. Then the fertilizers, the compound which provide essential nutrient to the plant such as nitrogen, phosphorus and potassium, or also known as NPK. So what is the purpose, how plants can get nitrogen is from nitrates or ammonium salt, phosphorus from phosphate salt, and potassium for potassium salt. Nitrogen help plants to grow well. Potassium is there for the fruits or the flower, and phosphorus is there. It is used for the better root system, the plant to have a better root system, we use phosphorus. And whenever we want to provide fertilizer to the plant, like NPK, that you can also say fertilizer or NPK, N means nitrogen, P means phosphorus, and K means potassium. So we should always use a compound which can dissolve in water, because plants are not taking a solid food, they are taking solution. So the fertilizer should be water soluble. So example, like if I say ammonium nitrate, so which, what is the essential nutrient it can provide nitrogen only. But if I say potassium nitrate, so what elements this can provide, it can provide potassium, it can provide nitrogen. And if I say I have ammonium phosphate, so if you have ammonium phosphate, what it can provide nitrogen, it can provide phosphorus. So there are different types of compounds or fertilizers depending on the use. Like example, whether we want the plant to grow faster, we want the better roots, or we want to increase the growth or the quality of the fruit or the flower, then it need potassium. So compounds of nitrogen, phosphorus, potassium are used as the fertilizers and improve the agricultural productivity. The plants need nitrogen, potassium, phosphorus in order they want to grow well. And but they cannot absorb the pure element, so the element should be in a soluble form. Then the test for the ammonium ion or ammonium ion, when we add an alkali, it will give out ammonia gas. So ammonia gas is produced by a displacement reaction which involve ammonium salt. So whenever we have ammonium salt like ammonium chloride, ammonium nitrate, and we add an alkali, so there will be a displacement reaction. As a result, it will always produce a pungent gas or ammonia gas. So this is the test for ammonium ion as well. We add sodium hydroxide and heat. A pungent gas is given off, which will turn damp red litmus blue. Then the carbon dioxide and methane, the carbon cycle. So the carbon cycle, this is about the carbon cycle example. The plants absorb carbon dioxide from the atmosphere by photosynthesis. But the plant can also respire and decay, break down, so they can release that carbon dioxide back. Or plants are eaten by animals and animals respire and they can release the carbon dioxide. Or the plants turn into a fossil and then we burn the fossil, it produces carbon dioxide. So this is a carbon cycle. So combustion increase the process which increase the amount of carbon dioxide, respiration and decay increases the amount of carbon dioxide, combustion increases the amount of carbon dioxide, this also increase, but which can decrease, like photosynthesis, the process can decrease the amount of carbon dioxide in the atmosphere. So formation of a carbon dioxide when we burn something, respiration, when reaction of acid with carbonate and thermal decomposition of carbonates. So carbon dioxide is emitted by respiration and combustion, and carbon dioxide is absorbed to make carbohydrates in photosynthesis. An animal eat these plants. That's the same thing, summary of the carbon cycle, that elements eat those plants and the carbon consumed and release form during respiration, and these animals eventually die and decomposer feed on these dead organisms and carbon dioxide return to the atmosphere. The last one is a methane. Methane is CH4. How the methane is produced? Production and use of fossil fuel, that is like fossil fuel like crude oil. They also produce this methane gas. Livestock farming, because the animal waste or cow waste is continuously producing methane gas. Or decomposition of vegetation, like organic matter, when it decomposes, it also give out methane gas. So these are the sources of methane. It can be produced by fossil fuel, production and use of fossil fuel, livestock farming like cattle farming, and decomposition of organic waste also produce methane. And methane is also a greenhouse gas. So this was all about the chapter air and water. Any question related to the class today?